This is lesson 12.1, which is the very first lesson in the probability section of this course. And the learning target for the lesson today is going to be I can find sample spaces and probabilities. So please make sure you write that down on your note sheet there. And then of course that I'd like you to use pencil to complete this notes assignment. And let's start with the vocabulary. The vocabulary for this lesson is important because it's new. I'm not sure that many of you have dealt with these vocabulary terms before, and it's a good idea to really learn about each one of them because they are going to matter in the examples that we do, and then of course the assignments that you do in the classroom. So a possible result of an experiment is an outcome. So we are going to be listing all of the possible outcomes of different types of experiments that we do, or different types of problems that we're going to look at with different types of probabilities. So we need to know that an outcome is a possible result of an experiment. Next we have an event. An event is an outcome or a collection of outcomes, such as rolling an odd number. So a specific thing that could occur when you do a specific experiment. So rolling an odd number on a die would be an event. The set of all of the possible outcomes is called a sample space, and often these look like different things inside of brackets like this. So when we go ahead and list all the possible outcomes, I'm going to put them in those brackets so that you can recognize them as a sample space. It's the result of all of the different outcomes. All are going to go inside of these brackets. So it's important that you know what those represent. Those brackets represent all of the outcomes of a specific experiment that we do. The probability of an event is a measure of the likelihood or chance that the event will occur. So something could occur how many times, what's the likelihood that that specific thing will occur. So if we go back up here to looking at rolling an odd number on a die, there are 3 odd numbers and 3 even numbers. So it's half, there's 50% probability that we would get an odd number and 50% chance that we would get an even number when we roll a die. So that's what we mean by the probability of an event taking place. The odds of an event compare the number of favorable and unfavorable outcomes when all outcomes are equally likely. So the odds of rolling an odd number on a die are the same as rolling an even number. So we would have 3 out of 6 to roll an odd number, and 3 out of 6 would be unfavorable because we'd be rolling an even number. So all of these terms are pretty much new to you. So as we go through this lesson, it's important that you write down any questions that you might have so that we can answer those questions in class. And let's go ahead and take a look at our first example. The first example asks us to find a sample space. Okay, so we're going to be finding a sample space and listing all of the possible outcomes in those brackets that I mentioned before. So the experiment that we're doing is that we're tossing 3 coins. Well, if you toss 3 coins, you could have 3 separate coins. One has, each of them has a head on one side and a tail on the other side. Or you could toss 1 coin 3 times, right? We could toss the same coin 3 times, which is the same thing as tossing 3 coins at the same time. But what they would like us to do is find the number of outcomes that are available in the sample space. So let's go ahead and take a look at if we toss a coin. Let's say toss number 1. Please write this down. In toss number 1, what are the 2 possible outcomes of tossing the coin? Well, we could toss a head, the head could show up on the coin, or we could end up with a tail showing up on that first toss. Well, what if we toss the same coin a second time? The second time we could get heads or tails again because there's only 2 sides to a coin. So if we got heads the first time we tossed that coin and we got heads the second time, then that means we would have gotten a head each time. But isn't it possible that we would also get a tail the second time, even though the first time we got a head? So we could also say the same thing over here. So what I'm going to do is I'm going to say, well, this is one route that we could get. We could get heads the first time, heads the second time, or we could get this route, heads the first time, tails the second time. Same thing here, we could have these routes. So I'm kind of drawing a little tree, and let's go ahead and draw in our toss number 3. So if we toss the coin the third time, our tree is going to have some more branches on it, because the first 2 times in this path right here, there were 2 heads so far, but couldn't I also get a head the third time? So really, if I toss 3 coins, there is a possibility that I get heads, heads, heads. And there's another possibility that I would get heads, heads, tails. Okay, so here's my other second route that I might get heads, heads, tails. And let me continue here. So I could get heads or tails each time, and the only reason I'm drawing a tree, a little branchy tree like that, is so that I can see all of the different outcomes, because remember, at the end I need to be listing all of them, and we're going to count them up in just a second. So let's just keep going with our little tree here. This is going to be a little bit strange because I'm running out of room. I didn't space it out enough. So here's a head and a tail and a head and a tail. So remember, there are only 2 things that could happen when you toss a coin. You could get heads on the coin, or you could get tails. And remember, we're tossing it 3 times. So here is another branch of that tree. We could get heads and then tails and then heads. And the last one here would be heads, tails, tails. Okay, so that's kind of how it works. I know it's a little bit hard to see once I'm done drawing it, but if you watch the video while I'm drawing it and you can see how I'm outlining them, then it'll make more sense. Okay, let's go ahead and draw in all of these different outcomes. So 1 outcome is the first thing I circled, then 2, then 3, then 4. Then here's a 5th one. What if we get tails, heads, heads? Okay, then 6, 7, and 8. So we should list 8 different outcomes. When we toss these 3 coins, there are 8 different things that could happen. We could get heads each time. Okay, then we could get 2 heads and then a tail. Or we could get heads, tails, heads. And I am literally just going through the ones that I circled there. And then we could also get heads, oops, tails, tails. Now those are all 4 different outcomes that could take place, because in order, you know, if we toss 1 coin and we get this, you know, each time we toss it we get a head, etc. So I'm going to write the other 4 in. I could get tails first, and then the second time a head, and then the third time a head. And then I could also start with a tail, get a head the second time, but get a tail the third time. Looks like I'm going to run out of room here. I could get tails, tails, heads, and then I could also get 3 tails. Okay, so there's a total of 8 possible outcomes, and remember, this is called a sample space. So if we go back up to our vocabulary, what we just wrote down here in black is called the sample space. It's the set of all possible outcomes when we roll, sorry, not roll, but when we toss 3 coins. We could get a head or a tail each time, and those are the 8 possible outcomes. So I would like you to practice on your own coming up with a sample space for this next experiment. The experiment is that you are going to spin a spinner. Okay, so a spinner like in a, you know, something that maybe you're playing a game or something and you have a spinner. It has 5 congruent spaces numbered 1 through 5. So the chances of you landing on any one of these is going to be equal, because we're going to have exactly the same amount of space for each and every number. Now I know I didn't draw that perfectly there, but 1, 2, 3, 4, 5 on the spinner. And you spin the spinner first, and then you toss a coin. Well, we know that the only different outcomes that we could have from tossing a coin is heads or tails, and you know that when you spin the spinner, you're either going to get a 1, a 2, a 3, a 4, or a 5. Okay, so now you need to come up with all the different possible outcomes I'm going to give you a hint. There are 10 outcomes total, and I need you to list them, okay? And when you list them, please list them inside of brackets like this. Okay, so when you spin the spinner, you could get a 1, and you could get a head on the coin. Or remember, you could spin the spinner and get a 1, but then when you toss the coin, get a tail. Okay, so please write down all 10 of the possible outcomes that you could get. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There should be 10 of them in the sample space. So you can just write, I'll just give you a hint for the first one, 1 heads, 1 tails. Okay, so those are 2 of them. I think that can give you enough information to finish that sample space up. Let's go ahead and take a look at the next page. All right, so example 2 here asks us to find a theoretical probability. I want to point out that this word theoretical means that when you're looking at actual numbers, okay, so the actual numbers should help us find out an actual probability, something that should occur if we were going to do an experiment. Now, the word experimental probability, and that is not really on the vocabulary part of this lesson. Experimental probability means what do you get when you actually do the experiment. And so there's a difference between experimental probability and the theoretical probability. So if I actually gave you what this says, if I gave you a bag that contained numbered balls, red, blue, and yellow, what would happen when you actually pulled the yellow and the red and the blue balls out would be your experimental probability. But we're just trying to find out if we had this number of even numbered balls with these different colors and these odd numbered balls with different colors, then theoretically what should we get? You know, what would the probability be, but depending on just the numbers there on the table. Okay, so it says the table below shows the numbers of each type of ball. A ball is selected at random, so you're just going to reach into the bag and pull out one of the balls. What is the probability that the ball that you select is odd and yellow? Okay, so it's an odd numbered yellow ball. Well, the first thing we need to do is probably we need to add up all of the balls in the bag because we need to know how many balls are we pulling out of. What's the total number of balls? So if we add these up, 6 plus 8 plus 10 is 24. And if I add up all the odd, 11 plus 7 plus 8 is 26. So that's a total of 50 balls in a bag. So we're looking at odd numbered and yellow. Well, here's the odd numbered in this row, and yellow is here. So it looks like we're going to have a chance of pulling from 50 balls, but we only have 8 opportunities, 8 different balls that are odd numbered and yellow together. So 8 out of the 50 are yellow and odd. Well, I can reduce this and when I reduce it, I get 4 out of 25. So you always want to reduce your fraction of the probability to its lowest terms, and so 4 out of 25 is your probability of pulling a yellow, odd numbered ball from the bag of 50 balls. And so using this same information, you're going to finish up these on your own problems down here. So in exercises 2 through 4, use the table from example 2 to find the probability. So here they're asking you what's the probability that you choose even and red. So of course you're looking for the even and red intersection on that table. What's the probability that you choose a ball that is not odd and blue? Well, if it's not odd, then what is it? It has to be even. And what's the probability that a randomly chosen ball is odd? So all of the odd ones should be considered, not any of the colors, but all of the odd ones. And remember, we added up all of the evens and we added up all of the odds, so that should help. So just remember to reduce your fractions once you get them if possible. Now I knew I could reduce this one because I could divide 8 by 2 and I could divide 50 by 2, and that gave me my reduced fraction, and I can't reduce that any further. That's the lowest terms of that fraction. All right, so if you have any questions at all, please make sure you write some questions down. There's plenty of space at the bottom of this page to do so. And remember, the terms that you have on the front side are important to understand because this is all quite new. So good luck with those on your own practice problems.